Well, hello, members of 7th grade. Happy Mondays. Hope you're doing well. I love today's idea. We have explored similarity before. We will be exploring it further today. L97, similar triangles, and then we're going to take some time looking at something called indirect measure. Please draw these two triangles and label them the way you see. A little bit more labeling will be, I'm going to make this mark here. Actually, I'm going to make a statement right now. I'm going to make this statement. The triangle ABC is, do you remember what that means? Good. Is similar to triangle DEF. Now, in order to prove similarity, certain information has to be given. So here's one thing that I could show. If I showed this, one loop and one loop, we know that that single loop and that single loop would make angle A and angle D congruent. Now, when I go here and I put a double loop, and I put a double loop on angle E, once again, I'm saying that angle B is congruent to angle E. And then if I did a triple loop, that would be saying clearly that angle C and angle F are congruent. That's not the only way they show it, and on the next picture, we'll look at another way that they show this concept of congruency. But basically, this would make these two triangles similar, because a couple things we know about similar triangles is how it affects both their angles and sides. Go ahead and write this statement down, though. Similarity in a general way, in kind of if you wanted to talk about it with a third or fourth grader, is you'd always say that it's the same exact shape. So not just, oh, they're both triangles. Like, there's the same type of triangle, except that they're different sizes. As you can see here, triangle ABC and angle DEF are the same kind of type of triangle, and they look the same. It's just one's kind of bigger than the other, right? Now, similarity has very specific things happening in both angles and sides, and I wonder if someone could take us through the first statement. Go ahead, Johnny boy. Just the first one. Yes, Johnny boy, I want to get other people involved, so just if you could take us through the first one. Yeah, no problem. Number one, corresponding angles are congruent. Johnny boy, I knew I could depend upon you. Don't let the name fool you. Yeah. All right, and who could take us through number two? Yeah, sure. Susie Q. Oh, okay, thank you. Sides are fun. Oh, Susie Q, I can't. No. Sides are fun, but I'm not going to go with that. Okay, Johnny boy. Okay, yeah. Well, it could be said two ways, but I'll just say that the sides are proportional. You are right, Johnny boy. Took Susie Q down. Maybe she'll have a chance for redemption. We'll see what happens. Yeah, and this is true. Now, we've talked about this term before, corresponding. And we've talked about it in different ways, but in this case, if we're going to talk about corresponding angles, we would have to note that things like angle A and angle D are corresponding. They're like the same angle in different triangles, right? Or we could say angle B and angle E are corresponding. Now, we also have corresponding sides. So if you think about that, like something like side BC, right? What would its corresponding side be? Oh, okay. Go ahead, Susie Q. Little chance for redemption. Oh, thank you. Side EF. Good job, Susie Q. You have been redeemed. Well done. Yeah. Let's get in. Please draw this up and label it as you see it, 5, 3, 6. And then we're going to make some marks here, which will be showing onto another triangle here. So hold off on the marks for a moment. Then draw one that's slightly bigger and label that up with that. See how that's slightly different? Instead of the single loop, they're doing a loop with a single tick. That would say that those two top angles are congruent, or a loop with a double tick. That's another way it's shown. It's less likely, but Saxon shows it this way. They also show it the other way we looked at. You just need to be familiar with both. And so I'm going to mark this as 10. and I'm going to mark this as A, right? Now, we would know that these two triangles are similar because that third angle that hasn't been shown would have to be the same degrees, right? Because there's only a limited amount of angle measurements, so 180 is the total. So in that these two are similar, we would say that their sides are, we could say proportional. Another way of saying is the sides are in proportion, which means I can create a proportion for what like is a missing side, such as that side A. And that proportion can be me connecting this 6 and this 10 as a ratio. So 6 is to 10 as, and then I would connect the 3 to the A as 3 is to A. Then, are you ready? 1, 2, 3. Now I'm going to go ahead and multiply through just because I know the relationship that's going to come out of it. 6 times A is clearly 6A, and 3 times 10 is clearly 30. Then I'll divide both sides by 6, boom, and I end up with A is equal to 5. I can box that up, yeah? I know we've done that kind of stuff before. So let's get into some stuff that we haven't had as much experience with called indirect measure. An indirect measure pretty much has to do with the sun and shadows, which who doesn't love the sun and who doesn't love shadows, chasing shadows. And so what I mean by that is, let's say I had the sun. Yeah, go ahead and draw up the sun. And then let's say I had a tree. Go ahead and draw a tree. And let's say I had a person. Now what's going to happen is that sun is going to create a shadow onto the ground because it's like backlighting these things. So here would be my shadow for the tree. Here's my shadow for the human. And what happens is these sun and shadows essentially create little triangles, right? Kind of imaginary triangles. And guess what? Those triangles are similar. So the sun and shadows create similar triangles. So if I was to label certain things, let's say this human is 6 feet. Let's say that human shadow is 8 feet. We are able to measure the shadow on the ground, easier than measuring the tree. So let's say I find out that the shadow on the ground is 20 feet. And the question is, how tall is this tree? So I'm going to mark it with an X. I'm going to write the question, how tall is the tree? Well, because these triangles are similar, that means I can create a proportion to describe them. So if I say, okay, 6 is to 8. 6 is to 8 as, I got to connect that 6 to the other kind of height side. That would be my X, right? X to 20. X is to 20. And are you ready? Yeah, me too. 1, 2, 3. I'm not going to actually multiply through here because I see some nice cross-canceling opportunities. So I'll say 8 times X is clearly 8X. 6 times 20 is, I'll just leave it 6 times 20. I'll be clearly dividing both sides by 8. And then I could do the 6 and the 8, so that would be 3, 4, right? Because their GCF is 2. And then the 4 and the 20, so that 4 will become 1 and 20 becomes 5. And then I could claim that X is equal to 3 times 5 is 15. And then don't box that up because I want to answer the question, how tall is the tree? What are we talking about, feet here? So 15 feet. And that's something I could box up, huh? And that's called indirect measure. Kind of cool, huh? Let's try a couple more. Let's look at this situation. I've got a flagpole. I've got a flag shadow. I've got a meter stick. And I've got a meter stick shadow. And the question is, what is the height of the flagpole? So go ahead and draw this all up. Remember what's being created here are similar triangles, right? And because they're similar, that means their heights and their distances, that they're all in proportion, right? These sides are in proportion. So if I take this X and I connect it to my 24, that would look like this. X is to 24. Now you might then say, wait a second, so I know I have my 40 centimeters, but they don't tell me how tall a meter stick is, which we had a laugh about this a couple of years ago. I mean, everyone was like, you need to know, they don't tell us. And I'm like, well, it is called a meter stick for a reason, and meter sticks are precisely 1 meter. That's why they call them meter sticks. And we should know that 1 meter is exactly equal to 100 centimeters. So I'm going to use that. So I'll say 100 centimeters, or 100, is to, there's my 40. I'm not going to multiply straight through, but I am going to do this on 3. 1, 2, 3. So x times 40 is 40x. 24 times 100, I'm just going to leave that out. 100 times 24, I see some nice cross-canceling. Let's divide both sides by 40. I'm going to cancel, basically divide the 140 by 10, so boom, boom. Then I see that 4 and the 24, so the 4 will become 1, 24 becomes 6. And then 6 times 10 is clearly 60. Once again, I want to answer this question, what is the height of the flagpole? Remember that it's feet, and say, oh, okay, 60 feet. And that's a good answer. That can box up. All right, uno mas. Please write it down. Brad saw that his shadow was about one big step. One big step is about a yard or 3 feet. He walked along the shadow of a flagpole and measured it as 8 big steps. Brad is 5 feet tall. How tall is the flagpole? And again, some of you might just be prone, well, I'll just guess, but please don't. But I do want you to predict right now. What do you think it's going to be? Is it 15 feet? Is it 24 feet? Is it 40 feet? Or is it 60 feet? And I would think your best bet here is to draw a little picture. So we got Brad. It says his shadow is 3 feet, and he is 5 feet. So if I draw up Brad, I'm going to label his height as 5 feet. I'm going to label his shadow as 3 feet, because that's what they told me. They told me it was one big step. Then I've got my flagpole. We'll go with the purple flag. The shadow of the flagpole was 8 big steps. Well, 8 times 3, that's going to be 24 feet. And what they want to know is how tall is the flagpole. So I'll mark that as an X. And then remember, these are similar triangles, so I can create a little proportion. 5 is to 3 as X is to 24. Once again, I won't do the actual multiplication. So ready? 1, 2, 3. So we'll go 3x is equal to 5 times 24. I have that nice cross-canceling when I divide by 3, because the 3 and the 24, x is equal to, was your prediction right? Did you choose 40 feet? Because if so, you were right. Good job. Yay. Hey, it's a Monday. And so we have the split, HW96 in /97. Hope you're doing well. Remember, you can reach out to me anytime. And hopefully you enjoyed today's lesson. I love indirect measure stuff. I think it's kind of cool. And there's a whole realm of geometry that goes deeper and deeper and deeper into this, which you'll enjoy at one point in your life. Bye.